So our goal today is to review specifics for the solution and to touch on analysis tasks. On Tuesday, we covered acquisition tasks. One of the things that we mentioned was detail related to, actually, I'm going to go ahead and close this. We've got it here. So when we talk about volatility, as you're just to recap, from Tuesday, if we're looking at acquisition, one of the most important things is to understand the two live types of acquisition, live and static. And you're conducting both in the first solution. So you're logging in remotely to a screen that is operating actively for collection of live digital evidence. And then you're also using two different methods to capture the contents of a USB drive. So you'll use Imager and you'll use FTX or FTK Imager to create two separate captures of that USB drive. And that's what you're doing for acquisition. One of the things that we mentioned on Tuesday is this notion of volatility, that you have certain types of evidence that are more volatile than others. And there are 5 groups of evidence that you want to look at first, if possible. CPU registers and static RAM cache on the chip itself, the process table, running services, kernel statistics, ARP and routing tables. Those are things that are really volatile. They're the most ephemeral, the kinds of things that can disappear in a flash. In the interest of time and complexity, your live digital acquisition isn't focused on this particular group of evidence. You do have active memory dumps if you have the right tools running on the machine. Unfortunately, AFES, AFES, the Association for Endangered Species, our notional organization, the nonprofit organization, is not the kind of company that has invested heavily in digital forensics or cybersecurity education programs, awareness training and education programs. They have not invested in EnCase licenses to run on each system. So this is their first encounter with digital forensics is your hire. And so we don't have the means in place on the live system to capture the contents of RAM. However, there are some things you could do to capture swap file contents if the system crashed. So group 3, swap file contents. Your page file memory or swap file is that part of system memory that you designate. Let's see. In here, if we go into advanced system settings or performance, and we look at the advanced tab, you have virtual memory. So when we're talking about this type of memory, we're talking about virtual memory. That's where temporary RAM content is exchanged out to hard disk for a special section of the physical hard disk. So, quick swaps of hard disk memory and RAM memory are happening on a system at every time. So there are ways to capture swap file contents if a live system crashes. as you're bringing the system up, you can boot it into a different mode and capture the contents of the swap file. We're not interested in running software on the live acquisition. In fact, your scope of interest doesn't allow you to change anything in running memory. Your primary interest is to help the leadership of AFIs to assess whether or not they're dealing with a scenario where it's just human resources and personnel, disciplinary actions. Is it an internal matter, or is there something more serious that's going on? When you look at group 4, whole disk partition and image capture, this is the type of activity that you're conducting with the USB thumb drive. You're capturing the contents of the USB thumb drive. At some point, if the scope changes, because they have to engage criminal justice elements or law enforcement elements, you may be allowed to capture the entire hard disk of the system. After certain decisions are made administratively, you may be able to pull the physical hard disk out of Sydney Corinth's workstation, in which case you can grab the entire contents of the physical hard disk, including the partitions, and then alternate stores of critical data. So you're talking about cloud, email, Facebook, and so on. As a matter of fact, you're going to be given an option. So as you begin your work to acquire data and digital artifacts, both live and static, and you begin your analysis, each of you are going to receive an email message. You're going to receive an email message from a mysterious personality out in Gmail, okay, Argentina Cabeza Hueca. So this is a mysterious, nefarious character, and what's going to happen is that I'm going to send you this email to your UVI email address. Okay? And so to simulate live conditions, you've started work on Sydney Corinth's system. You've started to capture digital artifacts on the live system. You started work with the USB. So you're well underway with your acquisition. That's the first solution you're performing. Before you get started with the analysis solution, so we have two solutions in this module. Before you begin the analysis, the formal analysis, lo and behold, this email will appear in your UVI inbox. It's going to simulate a case where someone in the environment, the investigation environment at AFIS, is aware of your presence and what you're doing and how and what you're investigating. And they're going to try to influence, they're going to try to reach out to you and explain some things about the subject, Sydney Corinth, right? And so this is your opportunity to earn additional credit. So I want everyone to understand that this is an opportunity for additional credit. In your analysis solution, there's an extra credit section at the end that explains what you can do with the email. Okay? Are there any questions about this particular artifact, how it's not going to be something that you personally collect, but it's going to cross your path? You have an opportunity to collect this as an additional artifact while you're in the work of analyzing things, and you have an opportunity to process it further if you want for additional credit. Any questions?
How do we collect this? Like take a screenshot?
Oh, you're going to receive it in your email, your UVI email. I'm going to email it to you after this class. So it's not something that you're going to have to actively acquire. I'm going to role play the part of this nefarious person who's going to try to influence your investigation with this email out of the blue. Okay? Does everybody understand? And does that help clarify?
Yeah.
Okay. So it's a, it's a bit of a role play. You're not doing a screenshot of this. You're going to receive a live email from this account. It's an actual email from this account. Okay? And you're going to receive it live out of the blue later today. But your choice to work on it or not is really more a matter of your preference, right? So this is a chance for you to do some, some additional credit. And that's all up to you. If you have the time, great. If you don't have the time, that's all right too. Any questions about the email option for additional credit?
No questions.
No questions.
So like, how do you get the credit? Do you just see the email and answer?
You're going to, that's a good question. You're going to receive the email, and then as you engage the requirements and criteria for your second solution, you're going to see at the end of this, right, so we'll open this up here. I'm going to post the second solution as soon as we finish this class. The second solution is about analysis. So your first solution is about acquisition. Second one is about analysis. And so you read this after you've finished your acquisition solution. You read this. It has additional information. And then it talks about the email in the scenario. Okay, so here's this nefarious person who reaches out to you, and they perform this interference, basically. You formally have to do phase one of the solution, but there's an optional phase has to do with the acquisition and analysis of the email, right? So basically, you just follow along, and then you do the extra steps that are specified in the solution document if you want additional credit. Does that answer your question? Does that help clarify? All right. What I'd like to do is show you what you're going to do to remotely access this live system. You're going to receive a screenshot of these credentials. Okay? And the first and most important thing you're going to do if you have a Gmail account is you're going to sign out of your Gmail before you use this. But basically, everything you need to access this account is going to be in this small screenshot. Now, why wouldn't I email this outright? Well, the contents of email travels in the clear across the internet. And I don't want anybody just mucking with this because they intercept the email that I send out to you. And all of a sudden, the issues and stuff have changed. So I'm basically going to take a screenshot of this. But you're going to sign out of your Gmail account like I have. And instead of saying sign in again, you're going to say continue. And you're going to use another account. Is everybody clear about how this is different?
All right.
And then you're going to type in stxpenguinavenger@gmail.com, right? STX Penguin Avenger Now, when you sign in, you're going to use the password new tux for you. It spells out in leet speak, new tux for you. That's this value right here. And what's going to happen is that I'm going to get a confirmation ping. Now, why is it I'm going to get a PIN code? Well, you're going to sign up for a specific 90-minute block of time to access. Each of you are going to sign up for a specific day and time to access this screen, as if you had an appointment to appear with a supervisor in Sydney Corinth's office. And when you do, I'm going to get a ping on my, you're going to select get a verification code. You're going to select get a verification code at the 90 number. And I'm going to get a PIN code. I'm going to know who to text this to because I have your cell phone number. Or I'm going to email you the PIN code. I mean, if you don't want to give me your cell phone number, but I'm going to get the PIN code for you to log in. And this is how we keep people from messing with each other's Kool-Aid, right? So your designated time slot, I'm going to look and see, all right, who is it that should get this PIN code? And I'm going to text you this PIN code, right? That's what we're going to do. Now, what's going to happen for most of you is that you'll come into a Google screen. It might be a Google account screen. You may or may not see the remote desktop icon in the upper right corner. Probably not, unless you're familiar with using Google Remote Desktop. You may not have this option because your Chrome browser may not have this plugin loaded. So the best thing to do is to click on the URL and type in remote desktop.google.com.
No, will the instructions for this be available on Blackboard?
No, it's in this video.
So in this
So
video,
I'll record this video,
all right.
and then basically we're posting this online as soon as we, this, how to get in and the solution. You're going to want to replay this video.
All right then.
Okay. Now, that's a good question. You're going to want to avoid doing this. You don't want to set up remote access for your own laptop. So anyone who uses this account for our class can get on your laptop. You don't want that. Please don't do that. But you are going to click Banshee. And when you click Banshee, you're going to have a PIN code. It's going to be 98989898 4 times. And basically what we have here is the desktop of Banshee. So the next step is to expand the right column and to press Control-Alt-Delete. And Sydney Corinth is already logged in. Because she's already logged in, she's locked the screen. You're going to enter this password to unlock Sydney Corinth's screen. You're not logging in, you're unlocking the screen. Once again, you are not signing it, you're not clicking here to sign in as Sydney Corinth. She's already logged in, that's why it appears. I'm going to enter this password. And when I come in, it's likely that this start menu will trigger. You can go ahead and click on the taskbar or press escape. And if that doesn't do the trick, you can basically click on the desktop to the right just to clear the start menu. So that's another common thing that kind of throws people off. Remember, the trick in your live acquisition is to take screenshots regularly so that you have an accurate picture of what's going on. If you do this and you go full screen and then you collapse this menu and you press print screen from here on your keyboard, if you basically go to the top center, or if you expand your menu and you come out of full screen and just minimize your remote desktop window for a sec, right? What's going to happen is you can open up Paint or some other application, and the image from that desktop wasn't stored on the live system. It was stored on your system. So you're not modifying the memory of that desktop. You're going to paste, and now you have your first screenshot. You're going to want to save this because when you finish, I'm going to check to see that everything is the way it's supposed to be. Now, how do you ensure that the windows that are overlaid on each other are restored in the exact order you originally found them? Well, you're going to do something like this. You're going to take the foreground window. After you've had your first screenshot, you're going to minimize that. Take a screenshot, minimize that. Take a screenshot, minimize that. Take a screenshot, minimize that. And then you're going to, one at a time, investigate each of the active windows that are going on. We've already told you that when it comes to the browser, you can check the other browser tabs out. You can check other features or the system tray to see what's running, right? You can basically expand on this and just hold your pointer over it. You can check other tabs, just make sure you return to the original tab that was highlighted on that issue. So what do you do to restore it so you leave no trace? Well, you basically open up each of these in the order it was. That wasn't the order. It's actually this one, the other one that was open last, and then this one, and then this one, and then this one. And then you're going to click on the desktop. You're going to issue a Control-Alt-Delete. You're going to lock your screen. You are not going to sign out. You are going to lock the screen. You are not going to sign out. You are going to lock the screen. You are not going to sign out. As soon as you finish, I'm going to go to that screen, and if I have to sign in as Sydney Corinth, you're in big trouble. Now, I say that to be melodramatic. You know, there isn't going to be a red buzzer that sounds. You know, you're not going to be in trouble as a student, but you are going to lose credit because you basically left a trace. You're not supposed to leave a trace. You want to lock the screen and leave it just like Sydney Corinth left it. So at that point, once it's locked, then you disconnect. Any questions about how to work remote access using the STX Penguin Avenger at gmail.com account? There is one last thing I would ask you to do when you're finished with your 90-minute session and you've captured your digital artifacts. I want you to click on this in your browser and sign out. Because if you don't, if you leave a tab running, and then you get distracted and you open new tabs and then you sign in to your own Gmail account, now you're commingling browser tab data from two separate Gmail profiles, and things can get really weird that way. So I need your help to understand. I need your help to preserve. And basically, if you screw this up, you're going to affect others. So it's like real life. So we don't want you to stress over it. But if you make a mistake, the first thing I want you to do is to send me a text message that says 911. You do not want me to discover your mistakes. Let me say that again with plain clarity. You tag me in, I can support you and make it all go away. It's a lesson learned. You leave a mess for other students to find. You can't recover from that in terms of lost credit for the activity, right? You will lose credit on the solution, one or both solutions, depending on the nature of the, the mess up, right? So let me say that again. If you screw up and you make a simple mistake, it's just reflex, and something happens, send me a text message that says 911. And then that way I can recover the scenario and the environment so the next student doesn't have, a screwed up environment to work with, right? And then they turn in results, and then I'm looking at their submission and I'm like, why don't you have the same artifacts everybody else does? Oh, well, because my screen was all messed up. There may be a case where we have people who are engaging the system or clearing the system as I'm teaching a live class. Okay, so I'm going to put out a doodle poll. Does everybody know what a doodle poll is?
No. Explain.
I think I know what it is.
Okay, I'm going to send you a link, and it'll go to doodlepoll.com. And basically what you do is you fill out your name and you check the boxes for the time slots that you can do. And then based on everybody's availabilities, we'll assign you a day and a time where you can get on the screen for 90 minutes. Okay. So you're basically sharing your availability to engage the live screen. Okay. And we want you to have plenty of time. It used to be that you had 60 minutes. We're expanding that. 90 minutes is gracious plenty. You'll be able to take, dozens of screenshots. You'll be able to investigate a lot of things to your heart's content. You can take your time. You don't have to be rushed. Any questions before? See how I still have a sign out option? I opened a new tab. I signed out over here. See how I still need to sign out on the new tab now? Doesn't take much. We're tab happy. As Google Chrome users, we just open up 57 tabs, don't we? You want to be signed out completely of STX Penguin Avenger. We don't want folks to be half logged in on another screen, and here's another student 2 hours later that's trying to log in to do their stuff, and you're still signed in, right? So that's another thing that I assess on the background. Help us out, follow through, make sure you sign out completely once you're done. Okay. Any questions? So we talked about the alternate stores of critical data, the online stuff. You're going to get that email from a Gmail account. You're going to have additional things you can do for extra credit if you'd like in the second solution. Let's look at today. We're going to take a short pause, and then what I'm going to do is pick up where we left off. Let me check my notes here just to make sure we haven't. All right, we said leave no trace. We said 90 minutes instead of 60 minutes. If you use print screen on the local machine, okay, I think that's it. All right. For the ADS assignment, I wanted to revisit alternate data streams and something called a resource fork. So they're similar in terms of exploit. You're basically folding an active application inside another one. So as it runs, it's mashed. It looks like if you copy calculator, the example we used on Tuesday, we copy calculator, and then with when you run paint, if you run you can run calculator, and what it shows up on the system as is paint. So there's a lot of malware that's hiding behind other screens. So this is the second document is available for additional information, but the first document is the one you really want to take a look at. And essentially, this is where I take a little time to explain the key points for alternate data streams. It was originally designed to help with compatibility issues for the Mac. Mac computers were not, didn't play nice with Microsoft computers. And so they actually invented ADS for a serious purpose. Essentially, when you have something that's embedded inside another executable, so this is conceptually similar to steganography. With steganography, I have a JPEG. I have an image that I've captured. And with steganography, if I use those hacker tools, I can take a data file and actually embed that data inside the JPEG image. There's a lot of empty space inside a data file. So I'm folding this thing inside the other file. That's what we're doing with steganography. With alternate data streams, you don't see what's going on with a file unless you use the /R option for directory. And when you do that, you get a chance to see if something has been embedded inside another software program. Hang on just a second. I need just a minute here. I need 60 seconds. I'd like to recommend something to you in the way of study habits. So basically, if you look at the Blackboard website and you go into references, study guide is 9 pages. It's not terribly long. The addenda is some additional pages, and there are other references. But basically, if you run across a term or concept in the study guide, you can either look up in your textbook, or you can go into the presentation slides, and you can look up related information on that concept in the presentation slides. Now, there may not always be information in there. It's not as efficient to try to read chapter 3, 4, and 5, 9, 10, and 11 in the textbook, and then look at the slides, and then go back and read the study guide. I would memorize this study guide and the study guide addendum, and then I would use your online textbook and and go to the index and search by terms just to see if there's additional information in there. That's just one recommendation I would share. Active or alternate data streams is one of those special topics, but it's between forked resources and alternate data streams. Malicious actors on systems use that method so often to hide data, just as they use steganography to hide data inside JPEG images, or they change the extensions, right? Another common thing, they change the extension of a file so that it opens in a different application and it looks like Chinese gibberish on the screen. Those are the high points, and that's where your primary focus can be. In any case, when you're issuing this command, a lot of times people don't get a good result because they don't put a space here between the slash, the forward slash, and the R. If you want to know that one of the best ways to understand ADS is to perform it, which is why it's an assignment. So we're asking you to basically to create an anchor for the hidden data. So if you follow these steps in the reference for the assignment verbatim, then it's pretty self-explanatory. We've got screenshots to explain things, right? So you can see exactly what you're doing and follow along. If you find that in the process of following these steps that you're lost or it isn't making any sense, then I would suggest backing up and just double checking. A lot of times, you know, we're multitasking and we miss a step and something doesn't work because we missed a step. If you're still sure that you followed all the steps and it's not playing out for you, then you can send me a text message. I may even have a video where I walk through this. I'm not sure I do, but if I don't, I can create one without too much trouble. I'm not sure that creating live videos of every method and every step is a good practice if that's what we do all the time. I'm counting on your ability to read and follow specifics in a written format on your own on occasion. So that's one reason why we have some assignments that don't have videos, but I don't want that to be a frustration for you, okay? I do want you to experience what alternate data streams is like and how it works so that you know what you're looking for when you get on the live system or you get some of the data store from that system, okay? Any questions about alternate data streams? All right. So I did say that you're going to have another solution posted for the analysis part. So AFI's data analysis will be posted, and you'll basically have another set of tasks to perform. And in that case, you're using Autopsy. Autopsy runs in Kali Linux, and it's essentially a web-based, so it runs in a browser. It is a web-based environment to provide graphical options to users for commands that are otherwise character-based. So it's just a front-end GUI. Autopsy is a front-end GUI for forensic operations that you can otherwise perform from the command line. I need to pause again for just 60 seconds. Please stand by. As you look at your study guide, essentially the early student learning objectives have more to do with acquisition. And then when you get to the final student learning objectives, those have more to do with analysis. And in particular, we want you to perform analysis using autopsy. And so you simply start your virtual machine. And when you load your virtual machine with analysis, for the analysis part, so you're using Geiger in Kali to capture a copy of the USB disk. That version of the USB capture should be functionally equivalent, and the hash should match the same acquisition that you do with FTK Imager. Now, why would you use a Windows tool like FTK Imager and then use a Linux tool like Imager to capture more than one image of a source disk? What are you proving when you take that approach? What are you proving to the world when you do more than one capture and you compare the hashes?
Aren't you just like verifying the evidence and just double checking? I'm sorry.
Yes. What you're doing is validating that your methods are sound, because you can reproduce the same results with different methods. So you're proving to the world, hey, and to yourself, hey, this is a valid capture. Why? Well, because if I use a Linux tool, here's the file that was created from the Geiger capture. Here's the hash. And then you use FTX Imager in Windows, and you connect the USB drive, and you do the same thing. And here's the data file that's created from the FTK Imager capture. Here's the hash file. Oh, look, they match. You are validating your acquisition. This is a critical part of normal digital forensics operation, but it's also important criteria for credit on your solution. And I wanted to take some time to call that out just to make sure you were aware of all this. Did we cover network forensics at all?
I don't know if you did today.
Yeah, I think we may have touched on it on Tuesday. So one thing that we want to talk about is what inevitably happens after the first round of work is done in a forensic situation. Like with AFIS, you're going to get an email. You're going to get the sense that, oh my gosh, we have to change the scope of the investigation. So if you're doing what you're supposed to do, one of the conclusions that you should reach is that yeah, the investigation needs to be expanded. Now, you have to provide rationale as a part of your submission. So what am I saying? You can't just parrot what I said in class. One of the criteria for your submission is to, articulate any recommendations you would have for AFIS leadership. And you could be remembering this moment in our class and say, oh yeah, hey, based on the evidence, this first round of evidence and first round of work, You know, I would recommend extending this scope of investigation. I would recommend that it's a formal investigation. I would recommend that we involve law enforcement. I would recommend that we also perform network forensics live, right? So here's what's going to happen if we're role playing and I were the president of AFIS talking to you right now, I'd say, yeah, prove it. I don't understand why that's important. You know, this was a big mess. I wanted it to go away. We needed your help to figure out how to manage this effectively. You know, escalating this into a legal quagmire is not my example of, you know, how to help us effectively, right? And the point I'm trying to make here is you're going to be given opportunities in this environment to collect evidence. One reason that extraction is so difficult is because based on the scenario and the richness of the scenario from all of the references and resources you've been provided, it's kind of like an Easter egg hunt. And what you have to do in your submission, especially for analysis, is to work up an informal report that basically says, okay, there's more work that needs to be done. And you need to provide the rationale. You need to point to the evidence, specific artifacts, and say, here's why I'm saying this. This artifact indicates such and such. This artifact indicates an infraction of federal law. This artifact indicates deliberate intention, malicious forethought, right? Means, motive, and opportunity. You need to essentially help interpret the evidence in a forensically sound manner so that stakeholders can make appropriate decisions. One of the things that's going to happen is that you're going to have to do a little bit of legwork on the network side. So what we're going to do is give you an opportunity to dabble a little bit with malware analysis and also with network forensics. What am I saying? In your assignment scenario, I haven't added it yet. Well, yeah, I did. The name is going to change slightly. So after you perform your two solutions, the analysis criteria includes a miniature report, not a full-scale final report, but a miniature report, right? You're going to be formally reporting back to the stakeholders of AFIS, and you're going to essentially say, you know, hey, this is some of our findings. What's the next step? Well, a little bit of network forensics, right? And we're not just talking about ZenMap or Nmap. I wanted to share with you a little bit about the network forensics side of things. First, by talking about sockets. How many of you remember your CSC 243? Anybody remember CSC 243?
I won't lie to you, not well.
Well, yeah, all right. Okay. Yeah,
Yeah.
that's all right. So, yeah, all right. Let's pull up some. So what I want to do is have a quick refresher. You're going to use Nmap. You're also going to use GRC Shields Up, and you'll use NetStat. Okay. It's going to be painfully obvious when you get on the live acquisition that there's some stuff that's going on across the network, and it's not good, and there's additional information that's needed, right? And from your time way back when in a galaxy a long time ago, when you took CSC 243, we talked about sockets. So let's just take a moment to explain. When there's network activity going on between two systems, by standard convention, one is considered the server and the other one's considered the client. Does everybody remember client server?
Yes, sir.
Okay, so you have and the term server is not a reference to the classification of hardware in that platform. We're not talking about, oh, this is a big data server in a data center and look at all the hard drives. We're not talking about hardware here. We're talking about the role it plays. A server is defined as any device or system that's running a service, it's running a process, that's active, and it's listening for connection requests. It wants to provide resources and data. So any device or system that wants to provide resources and data to another system is technically considered a server. If you share music between iPhones, the iPhone that shares the music is a server. Does everybody understand that?
Yeah, that makes sense.
Okay, it's serving up the music, right? And the iPhone that's receiving the music, that would be the client receiving the music. That's a client, right? Now, in layer 4 technology, TCP and UDP, you have well-defined registered ports that are known for specific applications. So ports 0 through 1023 are registered internationally with the IANA as known server ports for known applications. And there are some exceptions. There are some well-known ones that go beyond 1023. But basically, it's important to understand that low-numbered ports that are registered usually indicate, okay, this is the server talking. Because when a server role is being performed, somebody starts a service or a process and they're listening on a port for a request to connect and to form a session. The client connects with their IP address and they pick up a port with a very high number, a random port, a subject to change port. Every session has a different port number. These are called ephemeral port numbers. And basically anything over 1024 to 49151, right, would be considered user ports. So even though the original traditional definition uses 5-digit port numbers for what are considered client ephemeral numbers, the important point is that there's some very high 4-digit numbers like 6,000, 7,000 that would be considered client numbers. Here's the important point. The client and the server both have to represent their IP address and the port they're using when they form the connection, when they form the session. When the connection is formed and the session is formed, the two elements together define what's known as a network socket, okay? So this is the server side because it's port 80. That's a registered port for web service, HTTP, or 443 HTTPS. That's a low number. So this is the server side of the socket. 12.48.195.7480 is the server side. And in this socket, this part of the socket is the client side. And you can tell that because of the high number for the port, okay? Now what's interesting to understand is that a lot of organizations only have one IP address. At your home, you can have 2 or 3 people that are simultaneously accessing the online banking or accessing Facebook at the same time. And that connection, that socket for each of those 2 different devices in your home are totally different, because even though the IP address, the public IP address that represents your home internet connection is the same for both clients, the random port that they pick up to create the socket to finish the connection and to form the session is different for each of those clients, right? They each choose a random number, and the odds of them picking the same number is astronomically high. So basically the important point to understand is how this works. You have low number range, you have a high number range. The low number range tends to indicate what you're dealing with. Now, when you have network forensic scenarios, you got to have a point to start with for information. And what I'm going to do is ask you to simulate the network forensic piece on your laptop alone. I'm not going to ask you to do it on Banshee. I'm going to say this again. To complete the network forensic assignment, I want you to perform it on your own system, not on Banshee. I want you to pretend, because this is a virtual scenario, that you're conducting a network forensic task to extend the investigation, right? But you're going to use your own PC or your own laptop to perform this. Any questions before we continue?
No questions.
You're going to go to GRC Shields Up. And you'll type it in just like this with a space here.
Oh,
But
Professor, are you trying to show us, because we're still on Blackboard assignment.
huh?
You're showing the Blackboard assignment browser.
I'm showing the Blackboard assignment browser. Oh,
I think.
okay. Thank
Yeah.
you. Thank you for that. You're saying I'm showing that. All right. I want to be sharing the whole thing. Should be sharing the whole thing. Okay. Do you see GRC Shields Up now?
Yes.
Okay. Thank you. Thank you, Amaya. I appreciate that. All right. So you enter this and you're going to select Internet Vulnerability Profiling. And you're going to click Proceed. And so the whole interest in performing two tasks, GRC Shields Up and NetStat, is to get initial network, live network information that you can use to investigate further with something like Wireshark or sysinternals, right? So you're going to click All Service Ports, this middle button here. And if you're familiar with this screen, I mean, this should be common. You should have seen this once already, at least in one of my classes. Yes, everybody's seen this?
Yes, sir.
Okay.
Yes.
And so while this is playing out, I'm going to go ahead and I'm going to perform, right? Perform a command called netstat-a, and I'm going to redirect the output to a temp file called netstat.txt. So I'm just going to go ahead and repeat this command. I'm going to hit the enter key twice because netstat has this unholy habit of like hanging and it just blinks forever even though it's finished. So that's going to take a minute to run. But what we have here with GRC Shields Up is a display of the lower 1000 ports, the server side. So what is this telling you? This is giving you a listing of network activity across the reserved ports. We're saying that your laptop or PC is active as a server. Your laptop or PC is both a server and a client. You want both. So what we're going to do is note each of the ports that are unshielded by the firewall. What we should be seeing is all green. And if you see any blue, that means that there are ports that are not shielded by the firewall. They're closed, but they're exposed, meaning there could have been previous activity on these ports and that session ended and the firewall hasn't closed it off yet. Or it could be the intent to engage. There could be a process that's going to fire off with a certain event, certain mouse click, certain date time, certain application start, access of a certain data file, right? Engagement of a specific software feature. enter a certain word in a search browser search option, right? So events can trigger these things. And so you have this process that's running behind and it's ready to listen. When it's listening, then somebody from the foreign host across the internet can basically form the connection on here. So it's either past activity or future activity that this could indicate. You want to use the text summary option here. And what you want to do is copy this. And when you copy this, you're going to want to save it in a text file, and then put it in that temp folder like you did the other file, right? This gives you the ports of interest to look at when you're using Nmap, when you're using Wireshark, when you're using sysinternals, you're getting information on the server side, what these things are involved with. What about netstat? Well, when you look at netstat, you have to do one more thing to the netstat output that's really important. I want you to type in ipconfig. And it's important to note the active network connection that was used both for Shields Up and for netstat. You're going to note this information because you want to clean up your netstat output. So it only shows the ports that were used for this IP address. No other network interfaces. You might have an Ethernet port that's unused, or IPv6 that's active, or a virtual machine with a network interface. All of those are going to be rendered when you run netstat. Half of that information is bogus. But what you want to do is go in here then, in your temp folder, once it's collected, and you want to view it. And you'll notice, like I said, there's a lot of stuff that really doesn't matter. But it's the things that are 1.11 that matter. So you're going to delete and clean up the things that don't matter. Now, this is kind of interesting. 127 is a loopback. I'm not sure why this thing's listening on loopback. Maybe that's normal, maybe that isn't. That seems kind of weird. But notice, all these different ports, and these are higher than 1020. These are higher than 1023. From here on down is higher than 1023. So all of these ports are what? Established, closed and waiting, right? That's information that's significant. I'm going to get rid of the rest. This is from a virtual machine. Yeah, I don't know what the rest of this is. Oh, here's some more from 11. That's UDP. So I don't want you to be indiscriminate. I'm going to keep the 127 because I think that's kind of weird. It's like, oh yeah, why do we have specific UDP ports in 127 that we're interested in? So I'm gonna call this out, and I'm gonna call the rest of that out, and I'm gonna save this. Okay, this is the client side. So what am I saying? You have two natures active at your laptop or desktop. You have a server side where it could be running processes and services, and it's waiting for a connection from a foreign host. Or on the client side, you have activity where something is open and waiting. It's waiting for this to fire off a process to request a connection from a foreign host as a client. So any of the high numbers are where your laptop or PC is requesting a connection of a foreign host. And I'm just saying that this is a great starting point. Between the two files, you have a starting point to begin investigating with Nmap, with Wireshark, with sysinternals. There's additional information that you can glean from the registry and from other sources to cross-reference this. So the two pieces of information, client side and server side, of active network interests, especially those that are closed and waiting. What is that, right? What would be sitting there idle waiting for something to connect, right? I mean, I know I have established connections too. And right now I'm doing an awful lot with you, sharing the screens, teaching the class, Zooming, recording the video that I'm going to upload. There's all sorts of other stuff going on in the mix here. So my system is an issue. It's not an ideal case. Here's something that you can safely eliminate also. Why would I eliminate this? What does this represent right here? Hello? Can I account for that? Do I know what that is?
It's GRC shields up.
Exactly. Exactly. I don't have to worry about those ports because I know I've connected to GRC shields up as a client on port 24, 84, 85, and 86. I can eliminate the GRC shields up because I know exactly what it is. All right. The main point of this is to understand that you have to have a starting point to investigate live forensic analysis. And this gives you the server piece. The netstat gives you the client piece. Off you go with Nmap, with Wireshark, so you can start a Wireshark session. There is one more thing I wanted to mention to you about Wireshark that's really important. Do I have 2 more minutes? Everybody got 2 minutes left?
Yeah, I do.
Sure.
Can everybody see what I'm typing in here?
Yes.
Okay. It's called a span port or a mirror port. So oftentimes what happens is that in a switched environment, a network hub operates, it's the most primitive kind of multi-port repeater. When people started using cables, Ethernet cords to connect network with wire, it repeated everything that everybody sent. It would just repeat all the frames that were sent by any client to anybody that was connected. This was bad in terms of security, and they came up with an innovation known as a switch. The switch isolates the traffic based on port and MAC address. So what happens is that when you go to the next state and you're ready to extend your analysis based on your initial information from the client side and from the server side, and you say to yourself, okay, I'm going to do some Wireshark stuff. There's 2 actions you need to take to run Wireshark effectively. The first action is to configure a span or mirror port on the network, which means that you need to configure a port on a switch that is designed to capture all of the activity for all of the ports and all of the MAC addresses, and it funnels all of that network traffic into the one port. And you have to connect to that port specifically. So on the network equipment side, you have to configure a span port or a mirror port so that you can capture all of the network activity on the local area network. You do that intentionally. You do that with the support of the leadership and the IT staff. They know what you're doing. They understand why you're doing it. You have to analyze the traffic from all of the clients to and from the clients. The only way to do that is to configure a span or mirror port. On the client that you use to connect to that port, you have to change the mode of the network card operation to promiscuous mode. So there's 2 changes, one on the server network equipment side, configuring a span port or a mirrored port. When you connect to that, you have to change your configuration of the Ethernet interface that you use to connect. Why isn't this loading? I want my virtual box. All right, so when you connect to run Wireshark, you're going to go into your settings on the network card, and you're going to change it to promiscuous mode. Usually you have to have it set in bridged mode, and then here it says promiscuous mode deny. You're going to say allow all. What that does is it changes your network interface card to accept traffic from everybody and everything. If you fail to make this change on the client side for the network interface you use to connect to the span port or mirror port, or you forget to configure the span port or the mirror port, either way, your Wireshark won't capture the network data. People go to a lot of trouble to learn some basics. They watch YouTube videos on how to get started with Wireshark, and it's a mess because they didn't do the network equipment configuration, or they didn't set their network interface to promiscuous mode before they started Wireshark. Both of those have to be set for Wireshark to work. That's why we're using Nmap for your assignment. Nmap does not require, ZenMap is the graphical user interface version of Nmap. Nmap is a network analysis tool that's going to give you some additional resources to analyze your local network. You're going to look at your results and you're going to compare them to what you captured for the server ports and what you captured for the client ports. You're going to look at the output from Nmap. So Nmap is very easy to use. It's very powerful. It doesn't require special configuration. In the interest of time and sanity, we don't have the infrastructure to duplicate or virtualize what you would do for a proper Wireshark analysis, but we're going to let you use Nmap. So in this final assignment, after your solution, your second solution is over, you're going to use Nmap after you do GRC and Netstat. You're going to use your own network environment at your home to simulate the office environment of AFIS. That's what I needed to share with you today. Does anyone have any questions? Oh, by the way, you can also check out another rich place for additional information is to do ipconfig and then do a display DNS and then redirect that to a file. And that's a great source of information also, because whatever's active in terms of your network connections, if there's any named resources in the mix, when you're referencing and cross-referencing these things, that's another something you can do natively with any desktop or laptop. Basically capture the DNS cache and then have a look at it after you finish checking out the other stuff. We wanted to give you the tools that were practical to use to get a taste for some network forensics. Once you get information from the network forensics side, you can delve into Task Manager, the processes and services, and then take it home across the finish line with sysinternals. So, any questions before we close for today? About what you're...
No, I gotta go. Plus, we're over time. I got things to do.
Yes, I know there are other classes coming up. Thank you for joining us today. I'll go ahead and post this recording online as soon as we finish. I'm going to stop recording